In this video, we're going to be doing a problem where we're going to be finding a force. In this problem, we have a 2,000-pound trailer sitting on a ramp inclined at 30 degrees. We want to know what force is required to keep the trailer from rolling down the ramp. So let's look at what information we've been given. So we've been told that the ramp has an incline of 30 degrees. And we were told that it was a 2,000-pound trailer. Now remember, the force F due to gravity is going to pull the trailer down the ramp and against the ramp. We're going to let W1 represent the vector of gravity pulling our trailer down the ramp. Now, because the force due to gravity is vertical and downward, we can represent the gravitational force by the vector F equals negative 2,000 times the unit vector J. Now, in order to find the force required to keep the cart from rolling, or keep the trailer from rolling down the ramp, we're going to project F onto the unit vector V in the direction of the ramp. And what that's going to look like is V equals the cosine of 30 degrees times the unit vector I plus the sine of 30 degrees times the unit vector J. And we know that because if V is a unit vector such that theta is an angle measured counterclockwise from the positive x-axis to V, then the terminal point of V is going to lie on the unit circle, and that's going to give us the components x comma y, which are really just the components cosine theta and sine theta, which we can then write as the cosine of theta times the unit vector I plus the sine of theta times the unit vector of j. Now going back to our problem, if we go to our unit circle, we can evaluate the cosine of 30, which gives us the square root of 3 over 2 times the unit vector I, plus if we evaluate our sine of 30, we're going to get a 1/2 times the unit vector of j. Now this represents our unit vector along the ramp. So the projection of F onto V is our vector W1, which equals our vector F with the dot product of vector V divided by the magnitude of vector V squared, all times our vector V. So let's first find our dot product of F and V. So here I've written F and V in component form, and we can go ahead and figure out the dot product of F and V. So we'll have 0 times radical 3 over 2 plus negative 2,000 times 1/2, which gives us a value of negative 1,000. So we can go ahead and plug that in. So now let's look at our magnitude of vector V squared. Well, V is a unit vector. If it's a unit vector, it means it has a magnitude of 1, and 1 squared is just 1. So we can replace this with a 1. So now we have negative 1,000 times our vector V. And we need a little bit more room, so let's just move that down right here. Move all that down. Which gives us that W1 equals negative 1,000 times radical 3 over 2 times the unit vector I plus 1/2 times the unit vector of j. Now the magnitude of this force is 1,000. So a force of 1,000 pounds is required to keep the trailer from rolling down the ramp. So because the magnitude of W1 is negative 1,000, we would need an equal and opposite force to keep it from rolling down. And so that's why we're choosing the force of 1,000 pounds.